I wanted to provide a little more on translations. So, given the variable in the first column, use the phrase in the second column to translate to an expression, and then continue to the phrase in the third column to translate to another expression. It's a little more practice here. So, number 3, the number is x. So, the reciprocal of the number is 1 over x. The reciprocal of the number decreased by 3. So first we do the reciprocal of the number, and you see that pause says this is completely separate. Decrease that by 3. For number 4, the number is y. So the reciprocal of y is 1 over y. And the reciprocal of the number increased by 2. So we do the reciprocal of the number and then separately increase that by 2. For number 5, the number is z, and the sum of the number and 5 is sum means add, so the number and separates the other part, 5. Then the reciprocal of the sum of the number and 5. So it's the reciprocal of the sum. So the entire sum is moved to the denominator. For number 6, the number is x. So the difference of the number and 1. Difference means subtract the number and 1. And the reciprocal of the difference of the number and 1. So it's the reciprocal of the difference. So that entire difference goes down in the denominator. For 7, the number is y. Twice that number means 2 times as much, so 2y. 11 divided by twice the number, so you start with 11 and you divide that by twice the number, 11 over 2y. For 8, the number is z, so triple means 3 times as much, so 3z. And negative 10 divided by triple the number, you start with negative 10 and you divide that by triple the number. So to summarize this section, ratios compare values, and they may be equal or in proportion. We can solve ratios in proportion with cross products. Work, distance, and unknown numbers are just some real-world examples of rational equation problem solving.